Hello everyone, myself Kavya. Here I am to explain the concept of a classification model to identify iris species. Let us know about the introduction. The iris flower classification is a classic machine learning problem where the goal is to predict the species of an iris flower like setosa, versicolor, and virginica based on four features: sepal length, sepal width, petal length, and petal width. Using the famous iris datasets, we apply and compare three popular classification algorithms: decision tree, support vector machine, and k nearest neighbors. And our code is from sklearn.datasets import load underscore iris. Load the famous iris datasets from Scikit-learn. These datasets contain feature of iris flower like petal length, sepal length, and length and width, and their corresponding species. From sklearn.model underscore selection, import train underscore test underscore split. Use it to split your dataset into a training set and a test set. From scalar.preprocessing, import a standardized scalar. Applies feature scaling to standardized data important for SVM and KNN. From scalar.matrix, import classification underscore report, accuracy underscore score. Use it to evaluate model performance with accuracy and a detailed classification report. Next, will explain by Kumar.
Hi everyone. From sklearn.tree import decision tree classifier. From sklearn.svm import SVC. From the sklearn dot of neighbors import k neighbors classifier. These machines have been learning models. Decision tree supports the vector machine and the nearest neighbors. And iSeries is equal to load iSeries, and X is iSeries dot dot data. Y is iSeries dot target. The X holds the features like petals of dimensionals, and the Y holds of the labels of one setosa and the variocolor of and two veronica. X underscore of train and Y underscore of test and Y underscore of train and the Y underscore of test is equal to the train train underscore of test underscore split and the X and Y the test is size of 0.3 and the random state is 42 of the classification of Y. Split data is into the 17 trains and the 30 hours of testing and the classifier ensuring that the other classes having evenly represented in the both sides. Scalar is equal to standard scalar and the Y underscore of a strain underscore of a scaled. It is it is uh, it is a standard form of the transformation of a data having the zero mean and the unit variations and the x underscore of test of a scaled is equal to scalar dot transform of the x underscore of test. These steps has been from the SVM and the KNN which has been sensitivity of the features magnitude. Next code is explained by Prajwal MP.
Python model is equals to decision tree. Decision tree classification random states is equals to 42. SVM SVC kernel is equals to linear random underscore state is equals to 42. KNN KNN is equals to K neighbors classifier n underscore neighbors is equals to 3. Decision tree classifier tree based model SVC support vector classifier using a linear kernel. K neighbor classifier uses three nearest neighbors for prediction. Training and evaluating each model. Python for name model in models item print of f n name results loop through each models. If name is equals to decision tree model dot fit x underscore train comma y underscore train y underscore pred is equals to model dot predict of x underscore test. Decision tree don't require scaling, so we use unscaled data. Else model dot fit of x underscore train underscore scaled comma y underscore train y underscore pred is equals to model dot predict of x underscore test underscore scaled. SVM and KNN require scale data. Print of accuracy, comma, accuracy underscore score of y underscore test, comma, y underscore pred. Print of classification report, classification underscore report of y underscore test, comma, y underscore pred, comma, target underscore names is equals to iris dot target underscore names. Print overall accuracy and detailed metrics like precision, recall, and F1 scores for each classes. Next will be explained by Bindu.
Hi, hi everyone. This is the result. The samples have been extracted from the Excel sheet, which is Setosa, Virginica, and Versicolor. It has 150 samples. In the conclusion, if the accuracy of the decision tree is 1.0, which is 100%, then it performs the best on the test set in the specific case. However, note this, if might change slightly with different data splits on parameters. It's still good practice to validate further with the cross validation if needed. Summary of this project is, in this project, the IRIS dataset was used to build and evaluate three machine learning classification models: decision tree, support vector machine, which is SVM, and k nearest neighbors, KNN. The goal was to accurately classify iris flowers into one of the three species, Setosa, versicolor, or virginica, based on four flower features. Model evaluation results are: decision tree has got the accuracy of 93.33%, and SVM has got 91.11%, and of the accuracy of the KNN is 91.11%. In this, the decision tree model achieved the highest accuracy. It classifies Setosa and versicolor perfectly and had slightly lower precision on Virginica, but overall performed the other models. Key observations of this are: all three projects or models perform very well, especially on the Setosa class, which is 100% accuracy across all models. The decision tree model showed the best balance of precision recall and F1 score overall. The SVM and KNN had slightly reduced precision for versicolor and virginica compared to the decision tree. Conclusion is, the decision tree classifier proved to be the most effective for this task, making it a strong choice for simple, interpretable classification problems like this one. The project demonstrated effective use of data pre-processing model, training, and performance evaluation. Thank you.